Today we will study chapter number 10, that is Transform Superstep. It is part 1 of chapter number 10 and it is the part of unit number 4. So what is basically a Transform Superstep? A Transform Superstep allows as a data scientist to take data from the data vault and formulate answer to question raised by the investigation. The Transform Superstep is the data science process that converts results into insights. It forms the process step as its source data, and it works for 5 different dimensions of the data vault. So the 5 dimensions are time, person, object, location, and event. And all these 5 dimensions, they are connected to each other. So as the diagram shows, all the 5 dimensions are connected to each other. It's called the high level design. So TPOLE is used. The Sun model, it's a technique that enables the data scientist to perform consistent dimension consolidation by explaining the intended data relationship with the business without exposing it to the technical details required to complete the transformation process. So Sun model is basically used for Transform Superstep. Now, person to time Sun model, here we are connecting a particular person to a particular time, or we can say that the person's data collected at a particular time. So the time at which the data was collected, or you can say the data is valid. So person will have the following information like the person ID, the first name, last name, and birth date. So in this example, the person ID is 1 and first name, last name is given, and the birth date is 10th of December. Now the time at which the data was collected is that means the person's time dimension. So the time dimension is given a time ID, that is 100, then the time recorded as the UTC time, local time, and the time zone is specified. Now the Sun model is constructed to show all the characteristics from the 2 data vault. Hub characteristics you are planning to extract. It explains how you will create 2 dimension and a fact via the Transform Superstep. From the figure you can see that the person dimension and the time dimension we are connecting using the relation, that is person born at time fact. So this relation is used to connect the person dimension to the time dimension. Now the template for any model, we have to take 2 different dimensions. We have to write the fact at the bottom, and the first column of every dimension is the key, a unique ID that is provided to the dimension so that the dimension can be identified. And then so this, suppose the first one is the person dimension, so person dimension will have a key and the time dimension will have another key, so the records can be uniquely identified. And at the bottom we can write the fact. So the person dimension can be connected to the time dimension by writing the fact that the person was born at that particular date and time. Now person to object Sun model. In the person to object Sun model, we are having the person's dimension, ID, first name, last name, and birth date, and we are having an object. So we can specify the object that is connected to this particular person. So object will have the object ID, species, and common name. Then the person connected to the location. So the person to location Sun model, in this the person is connected to a particular location. So the location will have the location ID, latitude, longitude, and the time zone in which the data was collected. Now person to event Sun model, in this the person is connected to the particular event. So a person will have all the information like ID, first name, last name, and date of birth, and event will have the event ID and the event name. So in this case the event name is born, so the person born in this particular event. Now Sun model to transform step, in this the person and time dimension, they are used for transform step. So transform, we have to build a data warehouse. Transform mission from data vault to the data warehouse. So we have to take the data from data vault and we have to store it in the data warehouse. Now, transforming with data science, so we have to have the good basics for data exploration and preparation from the data lake into the data vault and from data vault into the data warehouse, so that we'll be able to prepare the entire data warehouse for storing the data. Steps for data exploration and preparation. We have to go for missing value treatment. Why missing value treatment is required? That's because if the missing values are not treated earlier, then later on it may cause problems. Like if we are calculating the average age, mean, median, mode, so at that time it will create problems. So why the data values are missing? There are various reasons for the data values to be missing, because at the time of collecting the data, some data might not be available. So instead of just rejecting the data, we can consider the data for the time being, and later on we can find out the missing values. The data field renamed during upgrade. So that is also the reason migration process from old system to new system where mapping are incomplete. So this is also a problem. Incomplete tables required supplied in the loading specification by the subject matter expert. Data simply not recorded as it was not available. Legal reasons owing to data protection legislation such as the General Data Protection Regulation, resulting in not to process tag to the data entry. Someone else, bad data science people or projects make mistakes, and because of which the data might be having errors, and because of which also the data is missing for the time being. So these are all the reasons in which the data might be missing. We may migrate from old system to new system and the column might not be matching, or the mapping might be incomplete. Then the specific data may not exist, or it is generally not recorded, or if it is not as per the General Data Protection Regulation, then it may get rejected or ignored. Or we can have, if suppose someone has not collected the data properly, or the person is a bad data scientist, then also the other process may get affected. Now, technique of outlier detection and treatment needs to be applied so that the outliers may not change the values of the data set, and it has to be detected and removed. Isolation forest can be used. Novelty detection, perform an evaluation in which we add one or more observation to the data set. Local outlier factor, an efficient way to perform outlier detection is done by high dimensional data set to use the local outlier factor algorithm. So local outlier factor algorithm will be able to remove the outliers. Why feature engineering? Feature engineering is our core technique to determine the important data characteristics in the data lake and to ensure they get correct treatment through the steps of processing. Common feature extraction technique is binning. Binning is the technique that is used to reduce the complexity of data set, enable the data scientists to evaluate the data with an organized grouping technique. It's a good way for you to turn continuous data into data set that has specific feature that can be evaluated for patterns. Like we can create bins of 0 to 5, 5 to 10, 10 to 15. In this way we can create different bins, and then we can put all the data that belong to one particular bin. Say all the data from 0 to 5 will be put in first bin, all the data from 5 to 10 will be put in the second bin. In this way, binning helps in averaging the data. Averaging is another technique. Use of averaging enable us to reduce the amount of record that we require to report any activity that demand more inductive rather than precise total. So there we can use the averaging technique. Now, hypothesis testing. Hypothesis testing is the process by which statistical tests are used to check if a hypothesis is true by using data. Based on hypothesis testing, scientists choose to accept or reject the hypothesis when event occurs. It can be tend to happen by chance. to check whether the event is important occurrence or just it has happened, hypothesis testing is necessary. So hypothesis testing, based on hypothesis testing, the query can be rejected or accepted. So first comes the t-test. It's a popular statistical test to make inferences about single means or inference about two means or variance to check if the two group means are statistically different from each other where n less than 30 and standard deviation is unknown. So, chi-square test, it's a squared test used to examine if two distributions of categorical variables are significantly different from each other. So like if suppose the marriage age and qualification of a person is known, so we can find out what is the reason for getting married or not getting married if there are two variables. Now, overfitting and underfitting. Overfitting and underfitting are the major problem when data scientists retrieve data insights from the data set. They are investigating. Overfitting is when the data scientists generate a model to fit a training set perfectly, but it does not generalize well against an unknown future real-world data set. As a data scientist is so tightly modeled against the known data set, the most minor outlier simply does not get classified correctly. The solution only works for specific data set and not for other data sets. So that is overfitting. Same way, polynomial features. Polynomial feature extraction can use a chain of polynomial formulas to create a hyperplane that will subdivide any data set into the correct cluster group. The higher the polynomial complexity, the more precise the results that are achieved. Common data fitting issues. These higher order polynomial formula are, however, more prone to overfitting, while lower order formulas are more likely to underfit. It is a delicate balance between the two extremes that support good data science. Precision recall. It's a successful measure for successfully predicting when classes are extremely imbalanced. In information retrieval, precision is a measure of result relevance. Recall is the measure of how many truly relevant results are returned. So precision recall curve shows the trade-off between precision and recall for different threshold. A high area under the curve represents both high recall and high precision, where high precision relates to a low false positive rate and high recall relates to a low false negative rate. High scores for both shows that the classifier is returning accurate result as well as returning majority of all positive high recall results. Sensitivity, specificity are statistical measures of the performance of a binary classification test, also known as the statistics as a classification function. Sensitivity, also called the true positive rate, the recall or probability of detection, measures the proportion of positives that are correctly identified, such as the percentage of sick people who are currently identified as having a particular condition. So that is the true positive. F1 measure. F1 score is the measure that combines precision and recall in harmonic mean for precision called receiver operating characteristic analysis curve. A receiver operating characteristic analysis curve is the graphical plot that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. The ROC curve plots the true positive rate against the false positive rate at various threshold settings. The true positive rate are also known as sensitivity recall or probability detection. Cross-validation testing model. Cross-validation is a model validation technique for evaluating how the results of statistical analysis will generalize to an independent data set. It is mostly used in setting where the goal is the prediction. Knowing how to calculate tests such as this enables you to validate the application of a model on real world, that is independent data set. So with this, we have completed the part 2 of unit number 4. Thank you.